Welcome everybody. This is Python Frederick, and I am Matt Lehman, and tonight we're going to talk about types in Python and what they are and how you can use them and how you can leverage them and make them useful to you and make your code writing experience better. So I've titled this Give Me a Type Hint. We're going to look at hints and annotations and all that sort of stuff, and I'll explain what that means as we go along. So I'm going to start with the basics of what is a type, and we can figure out what types are in Python by asking Python. There's a built-in function called type, which will then answer the question, what type is a piece of data that you're working with? So we have some stuff on a REPL at the left, excuse me, I'm backwards often with those things. And we've got some stuff on the left, and if we advance one more, we'll see what the types of these things are. This is the representation that would spit out in the REPL if you're actually just typing this out. So ignore the angle brackets and the class stuff. The stuff in the quotes there are actually the types. So we have a string and an integer and a boolean and floats, and if you've done programming for any length of time, you've probably seen similar types in other programming languages. They might capitalize certain aspects or call it something slightly differently or name the full thing, but it's the idea that your data is a certain type of thing. It's a kind. And we also can see at the bottom here that you can have custom types. So when you make a class in Python, which is what I kind of showed with that last example, you can ask Python what is the type of this thing, and it is a custom thing that you added. So types are prevalent throughout Python. Everything has a type all the way up to, but I guess not including the types themselves. Is that a true statement? I think it's a true statement. But things are typed in Python. But Python is more than that. Like, you know, every language has some kind of notion of typing. There's attributes that are tracked along with what a piece of data is. It allows a computer to process that data to know whether it's adding an integer or dealing with IEEE floating point numbers. It needs to know that information. It's the question of how does it know it. Many languages will like a C or a C++, be very explicit about the types. It'll make you declare, this is my type. I'm going to put this kind of data and this kind of data only in this variable. But Python is like, whatever, man. It's dynamically typed. So what we have here is an example where the what am I is a variable, and initially it's a string because we assigned it that value. But nothing is going to stop you from the very next moment changing that type and saying you're actually now a number, an integer in this case. And that's totally okay. Python's not going to complain. There's not going to be any fault of this. What it's really doing is kind of assigning the value to the variable, which is an object, and everything is considered to be an object that's looked up at dynamically whenever something is evaluated. So the key takeaway here is Python is dynamically typed. You're going to hear statically versus dynamically, and that's the consideration here. So let's consider, though, where are the types actually in the code? We've got this function here, this praise function that is pretty silly. It's just printing out you're amazing, and then it prints out a name. But then you can see two examples of different usage. One might be what you expected, in that case of a string saying, you're amazing, Adam. You're amazing, Mike. Like, those are things that you could expect out of this. But what happens when you pass in something that was not a string? Well, in this case, it turns out that Python knows what to do with a true, and so it will actually print out true as a string representation. But you can imagine that there are times where the types wouldn't be so nice. So imagine if you were doing, for instance, a division, and you passed in a string. Does anybody know what kind of error you'd get if you tried to take a string and divide it by some number? A type error. Yeah, exactly. Yeah, these are not meant to be trick questions, y'all. So yeah, it's going to raise an exception. It'll be a type error, and there'd be problems with that. So the dynamic nature of Python is a double-edged sword. It's like it's super flexible. It allows you to quickly write something down. You don't have a bunch of stuff cluttering up your code necessarily, but that conciseness comes at a potential cost. And that cost is like you don't know for certain what some kind of data is going to be. So the important part about this, though, is that types are known only at runtime. It's when this code actually runs, when that function is actually called. That I'm referring to name in this case. That's the bit that's only known at runtime. We don't know it in advance because of the way it is described here. That's the default mode of Python.
For dinosaurs.
For dinosaurs, yes. There's another kind of typing that you might hear about that I'll describe for completeness. It's not really truly about typing, but it's this concept of duck typing, which is kind of just a cool thing to hear about and learn about. So I've described this example here where we've got two different things that can quack. We've got Dr. Nick, famous quack doctor from The Simpsons, and we've got a duck. And I've defined a function at the bottom called speak that takes some kind of quacker. And as long as the quacker can quack, it will run whatever that function is. So again, this is where Python's dynamic nature is actually pretty powerful. You can substitute one kind of object for another, and Python is like, cool, man, you've got a quack method? I'll call it, because it's there. So both of the calls at the bottom, where you have a duck object and a Dr. Nick object, one will say quack, and the other will say, hi, everybody. You know, it will do what you would expect it to do in this case. So it's pretty powerful. And there are ways that this, again, could bite you, but this is a very powerful technique that allows you to do things that may be harder to do in other languages. Like this would be harder to do in a statically typed language. You'd have to start working with interfaces or protocols or whatever your language is going to call it. It's not going to be as easy. Python just says, like, I'm going to try and call it, and if it's not there, anybody know what kind of error you're going to get if it's not there? Close. It's an attribute error. So if you try and call a method that's not on the actual object, it's going to raise and throw an attribute error saying, I don't know what this is. So I'm not going to do anything about it. So that's useful a lot of the times, but it can be a problem. Like if you're calling a none object, we can see none type errors. That's a pretty classic example of a Python error that can happen, where you expected one thing, but it was actually another thing. So it'd be nice if you could get a hint about what your code is doing or what the intent of your code was, and that is what we can do with Python. So there's this optional syntax that is not there by default, but you can use it if you want to. And the key part about this is to think about this in terms of inputs and outputs. So we've got a basic function that I just called afunc, and it has a single parameter, and it has an output, a return ultimately that you'd see at the bottom. So you can tell Python with this colon syntax and this arrow syntax of what do I want my inputs and outputs to be? What do I expect them to be? What can I declare them to be so that some other consumer, some other reader of your code in the future can say, oh, okay, I know what that is. So the colon syntax here says, I expect that whenever this afunc function gets called, the param is going to be a string. Similarly, the arrow says the return out of this function, I expect it to be an integer. So just by having this bit of extra optional syntax, you can do a lot of cool and powerful things. And this is the basics of what a type hint is. The idea is it's hinting at what the variables and returns are. The other fancier name that you might see if you actually go and read the Python, the PEP for this is a type annotation, is the more formal name. But they'll often get called hints. So we have some benefits for using type hints. You don't use them all the time necessarily, but when you do, they can express intent. So if you're an author, I expect my function to be used this way. This is especially useful if you're writing some library that you expect some teammate or some random person on the internet to use your code, and you say, hey, I'm telling you, this is how it is, man. Don't try and pass in your none because it's not going to work. So you can be very clear about what you expect on your functions, and this can also apply to methods and stuff. So I'm saying functions, but extrapolate to other things in Python can be declared what their types are. It unlocks editor superpowers. This is probably the biggest one. It's one I'm going to show you tonight, is when you've taken the time to add types to your functions and methods, then your editor can then correct you with the red squiggly, just like you're using a word editor and you spelled something wrong. Your editor can correct you and say, nope, you called it wrong, or hey, you passed in the wrong argument, and like tell you that this is the wrong type. That's very powerful, especially on a large team. So editor superpowers is a big thing. And frankly, you're going to get fewer bugs if you do this. These tools that you're going to see, they can catch things that you maybe didn't even know existed. Things that, like, in contexts where you're trying to pass in some kind of argument, you're trying to call some kind of method, and it's not allowed for reasons that were maybe just beyond your understanding of Python at the time, an opportunity to learn. So it will definitely have an effect where you'll have fewer bugs. In fact, I'm on a very large team. We have a code base that has hundreds of thousands of lines of Python code, and we mandate that we use the optional type hinting. It's not optional for us as our team because it's caught so many bugs and has reduced the number of defects that we've delivered to our customers. So we want to produce higher quality software, and we can write tools that keep us honest and make sure that everybody who's using my code, everybody who's using my functions, is going to do the right thing, because they can't check their code in if they're doing the wrong thing. So that's some of the power of having type hints. So I'm hoping, after going through this demo, that you will become, at some level, a typewriter. And sorry, I couldn't resist the bad pun. So we're going to jump over to a demonstration, and I'm going to walk through a bunch of kind of basic examples with types, and we're going to use VS Code to do it. Hopefully you've seen VS Code before, or at least played around with it. It's a pretty familiar editor, and then we will see how this all goes. I am not using Vim, not because I don't love Vim, but because I feel like you might be better equipped if you see it. I know.
He's got it right on his laptop.
So here we are with our demo. And actually, let me pause first. Does anybody have any questions about the idea of types as I've described it so far?
I have a hard question. Maybe you know the answer, maybe you don't. But because Python, unlike other languages, doesn't use these declarations where you have a type, a lot of other languages use that for memory allocation, among other things. How does Python allocate memory dynamically when the object may change and be dramatically different?
It's all heap, baby. The Python uses a ton of heap memory to dynamically allocate. So if you're not up on your memory stuff, there's the stack and there's the heap. And so this is a good question because it gets to like some of the questions about Python speed. If you have a language like a C where you can know at compile time, I have an integer. It's going to take 4 bytes because it's a 32-bit integer, or is that right? Yeah. And fit in this amount of space. And so the compiler can allocate at compile time how much memory is going to be needed for something to run, so that when the C code runs, it knows exactly where to stuff that integer to do the computation. With Python, because it's so dynamic, everything needs to be looked up before you do anything. Before Python does an addition, it needs to look and say, I have this variable, I see it as a Py object if you look at the C API, and then I have this other Py object, and I even need to ask, can these two things be added together? Like, you have to check every time, and that has a real performance cost. So that's the speed trade-off when you're using Python. You get the implementation time flexibility, but you lose out on some of the pure performance, which is why the things that need to be ultra optimized are often written in a kind of lower level language like a Rust or a C or C++ and so on. Answer your question?
Yeah.
Cool.
Yes.
All right, let's start. Can people see this code okay? Is this big enough? Great. Let's start with a basic function. But before I do that, in VS Code, I've already got the Python extension installed. That's a pretty easy thing to get installed. There are a couple ways to make use of type hints and type annotations. One is a very common tool called MyPy, and the other is a tool that is newer to me, but it's built into VS Code. It's called PyLance. It's from Microsoft. PyLance is, it turns out, a wrapper around another tool called PyWrite. I bring that up because when we're trying to talk apples to apples, you can compare PyWrite and MyPy. These are the classification of both these tools is they're called a type checker. So the idea is you provide the hints, you provide what you think things should be, and the type checker then is scanning all of the code and making sure that you're being honest with what you said things were. So you need, in order to fully leverage type hints and type annotations, you need a type checker to kind of pair with you. So I've already installed MyPy in this example. There is apparently a very easy way to get access to type checking in VS Code. I didn't know this until after I'd installed MyPy, so I think I might have just stuck with PyLance if I found it. But apparently you can click down here and there's a little thing that says, do you want to turn type checking on or off? So if you do that, it'll like activate PyLance and give your Python stuff superpowers, but it might get a little persnickety about some stuff. Okay, so that's the basis of the starting point. So let's start with the example that we saw kind of in the slide and start it with just some introductory stuff. There's nothing crazy about this, and there's no type annotations here yet. And then we'll just call it with a function with a value of 42. Now, based on this, you'd assume that param is some kind of integer. And you might be right, but I didn't express my intent clearly. What I really wanted was for a param to be a string. And I wanted the return type to be a Boolean. So I got half of it right, but now if I save this thing and everything's working correctly, oh, you can see that we have a problem. So it says a function has incompatible type, int. It expected a string. So it's really just keeping you honest here. So that's pretty cool. And then you can see if we change this to an int, whoops, if I can highlight properly. If we change it to an int, well, there it goes. So not a lot of extra code here. I think, what is this? 5 characters for the input parameter here, and then you'd have whatever that number is, another 8. So for a small amount of additional code, you get this checking that the function that you've created is now being passed the right kind of value. And this is really useful if you're doing any kind of like parsing. You know, like maybe you're doing a parsing of a JSON object and you're getting it from some data source that you don't really control. And this is probably pretty common, lots of APIs out there. And maybe you were trying to do some math on it. You thought some key in the JSON object was going to be an integer, but for whatever reason, somebody in their infinite wisdom decided to put quotes around their values. And so what was really happening when you were calling a JSON load is that you're getting strings for all of those values that were supposed to look like numbers. Now maybe you could cast it to an int, but you didn't know that. And there are ways that you can make sure that that payload that's getting passed in is checked so that you're getting the right thing. So that's one kind of use case here. All right, so that's the most basic version of type hints and seeing them applied. Any questions about that example?
How picky is it for numbers, like what you put the float or some other?
Let's try it. Picky.
I meant like on line 2 with 42.
Yeah. Yeah, so
If you kept 42 in line 6, if you change that to line 2 to float over another type, what would happen?
I think it would also complain because floats and ints are different. I would think. Maybe not. Maybe I'm wrong.
I was just wondering.
Maybe they would cast. There are other numeric types that kind of like can encompass multiple things, and we'll see in a minute how you can do specify multiple types. So it's there is a world where your inputs can be different types, and I'm going to show you an example of what that looks like, so that if you maybe numbers maybe not the best example, but you can think of other custom types where you could say I could handle a string or a custom thing that I made. You can do that too. But good question.
Where's your variable in there? Like if you actually wanted to do something with 42.
So that goes into the parameter of the function. So when you call the function, this is the terminology here is when you're calling something, it's an argument. So that 42 is an argument. And when it is executing in the context of the function, it's in the parameter, which I've named param here just for convenience. So arguments get bound to parameters when function calls happen.
So param you could have said George.
Right. Correct. Yeah. I could have called this could have been whatever I wanted.
Got it.
I could have called it George. You're right.
Thank you.
Yep. And that's just the local variable name that's going to have during the context of that function execution. Yeah. All right, cool. Let's look at this next one. There are times where you might need to declare the type of a variable. This is less common, but sometimes you might have a longer function or a longer section of code where you want some kind of data to be a certain way, and like you might change it, and these checkers can be like, hey man, you need to tell me what do you actually want here. You've reused this variable, you've called it something else, like the who am I thing from the beginning. What did you want? You have to sometimes tell it. So you can have a scalar variable and same kind of syntax, but it looks like this with the assignment. So it's a standard assignment syntax, but you've added the colon int here. When you have a list, you can do this kind of syntax. So I want a list of strings, and I'm going to have my list of A, B, and C. And so I could change this, and I could say 42, and it's going to highlight it and say, wait a minute, this element in your list, you said it's a list of strings. Notice that this is using square brackets, so it's kind of meant to hint at like this is an index-y looking syntax of these are the things in your list. So you care that the whole structure is a list, and that all of the elements inside of that list are of a certain type. I'm going to change that back to C just so I have some working stuff here this whole time. Finally, the other most common data structure that you would use is a dictionary. And in this case, you need both to describe the key and the value. So you might say stir with an int, and then have some example like hello, and just some number, some integer number. So that's how you do it when you're working with individual variables. Again, this is not something that you'll see needed as much, especially if you're pretty good about not reusing your variables and overwriting their values with new things. It's not going to come up very much. But these type checkers want you to be more explicit sometimes. So if it's confused, it might say, it looks like you tried something else here. I don't really know what this is. Is this what you meant? And you can be very explicit and say, no, I really wanted this. And I guess I didn't really plan this, but I'll throw one more bonus in there. So there's also a time, sometimes you might need to say, I don't really care what the types are as long as it's a dictionary or as long as it's a list. So maybe I have a list that is intended to be a mixture of different data types. I don't know what context you'd use that in, but this is stuff that can happen. Like, data's weird out there. And notice that the type checker is not complaining about this because I just specified I just want a list. Implicitly, what this means is there's something called the any type. This is good to know, that whenever you are not being clear enough about what it is, you're implicitly saying this type is any. And this actually comes from a standard library module. So in order to make this truly work, we'd say from typing import any. The typing module, the typing module is where a bunch of these extra pieces are that you might need to use. In fact, prior to the versions of Python that we're on right now, you used to have to use go to the typing module and say capital L list and capital D dict to do this typing stuff. Recent versions of Python have kind of streamlined that so that you don't have to bring in this typing module nearly as much. And in fact, in this case, I wouldn't recommend using this style. There's no reason to say square brackets with any there. I think that's just excessive. So we're going to take it out for now. But just know that that's where it is. If you ever had a type that you're like, I just can't describe this. Type is too complex for whatever reasons, you can use any. You're strongly encouraged to minimize usage of any because it is essentially just punting on the whole type checking process and saying, I give up.
Are there any types that come to mind that you still have to import from typing that are included in?
Yeah, I've got one. I'll show you one down here. There are a couple that are useful for sure.
So if we have like compliance requirements to type our stuff, we could just add any everywhere.
You could, yes, you could definitely type everything with any and be compliant for whatever team, but all your teammates might frown upon your behavior. All right, let's look at another one. This one's called there's a way to do optional. And again, this is one that used to be, or it still is in the typing module of a capital O optional. But we're going to look at an example and some syntax changes that have enabled you to do something cooler than that. So we're going to create a local parameter called string or none. And this is just the name to be really clear here. Like you could call this George if you wanted to. It doesn't matter. So I'm going to use the none operator to list that as the type. And then I'm going to try to take string or none and call one of the string methods built-ins on it, title. So title will take a string and it will, for every word in there, try and capitalize that first letter of each word. That's what the title method does. But because we added this or none, there's another thing that could happen, that could come in here. It's the variable, or the type, none. And this is a classic case where this would give you a none type, or actually this would give you an attribute error because the none is not going to have the title attribute on it, so it doesn't like that. So the type checker is trying to keep you honest and saying like, hey, you told me there are two different types that can come in here, but you have not handled this case. So in order to correct this function to behave properly, we can add an if clause, an if guard, on our string or none, and say, if you are none, then return something else. In this case, I'm just going to put nope. And it makes that type error go away, because the type checker is smart enough to realize, oh, you handled the case that I cared about. You handled the case where the variable was a certain type, and it's not possible to get to line 18 with the none type anymore. You've got the appropriate check in there. This is like in your Java code, your classic checking for is my variable null that you might see if you've ever done Java. Okay, so that's optional. Again, the other way to do this would have been, prior to this syntax being available, is to do it like this. And I'm going to show you because you might see this still out if you're looking at code on open source projects, where you could say optional and then have the type that you care about. So this is effectively saying it's a string or it's none. And there's a third way, just to be complete, there's another thing that comes from typing called union. And so you could say it's a string or it's none. So optional is a shorthand way of saying union of string and none. Does that make sense?
Those you have to import to use.
Both, yeah, that's why I'm getting the squiggle right now, because I've not.
I've actually used that one before.
Okay, cool. Yeah, so union is for like if I wanted a string or an integer, that's what I could do that for. Whereas when it was just optional, it's just implied that the other of the two values is the none type. Does that make sense?
What do you have to import to use that? What do you have to import to use that?
It's from the typing module again. So where I had any, you can do from typing import optional.
Okay.
And same with union.
It's kind of like a 3.7 versus a 3.8 versus a 3.9, right?
Yeah, I don't remember the exact version where, like, I think this is a 3.9 thing where you could start to use the pipe instead. Don't quote me on that, but I might be wrong. But it's a more recent version of Python that's been over the last couple of years.
In 3.6, if God forbid you're using it, you can't even import this stuff. I don't think from future import annotations works in 3.6 at all.
Yeah, that's a different thing, but I'll talk about that in just a second. Any questions about optional and this pipe syntax? This is a good, I actually, this comes up all the time. Like, unfortunately, the none gets propagated through code. And if we could eliminate none, that would be better code. But we can't. And so I will regularly, anytime I know that I have a value that is going to have some kind of none, I will always use this kind of syntax because it has saved my bacon so many times from none-type errors. None-type errors are some of the most prevalent errors, in my estimation, from all the Python code that I've written in the last 15 years I've been writing Python.
So that syntax works with variables as well, same thing?
Yeah, it should. Yeah,
Yeah,
like up here you should be able to do this.
Okay.
Yeah, good question. Okay, let's look at this next one. So this one is a bit more nuanced, but we'll see it. I'm going to write out an example first, and then we'll get into what's going on. I don't know that this is canon, so if you're a big Mandalorian fan or whatever, you can tell me. Okay. That's the code. It's meant to be a ridiculous example, but it illustrates the idea. And the idea is this. Notice there is a squiggle down here. Anybody know why there's a squiggle down here at this time?
So you're referencing the class from inside the class.
Yeah, but do you know why that's a problem? Good, you're right. So, and Mike's response was because I'm referencing the class from within the class. But do we know why that this is a problem?
It's not instantiated yet?
Yeah, but it's pretty close. So when Python parses this, what it's doing is it's building up the Boba Fett class, and it needs to attach all of those methods and parse all of them. And then only after it's done all of that parsing does it add the Boba Fett token back to the local module namespace. So but at the point at which I've called this, line 27, what Python parsing is not going to have Boba Fett available in the namespace yet. It hasn't been added because the class hasn't been finished processing. So that's the core of the problem here, is that, and that's why Boba Fett is fine inside the body of this method, but it's not fine in the signature. That make sense, people? All right, so there are two ways to handle this. One way is to do this and wrap it like a string. The type checkers will say, all right, cool, I'll go look that up later. And Eva gets like, VS Code is doing some cool stuff here, which is pretty neat, and highlighting it and saying, like, I recognize it's going to be a class, is kind of what we're getting at here. But if you threw up in your mouth a little bit with the syntax, you were right to do so. That's pretty gross, and it was just working around a limitation in the language. So instead, you can do something different. you can keep the cleaner looking style, which is what you want, the class thing. And at the top of your code, or I guess anywhere technically, but I'm going to add this from future import annotations thing. So it's a hint to the language of, hey, I want to use some features that are not in the not required for the current version of the language, but are available in a future version of the language. At some point, the behavior you're seeing down here will become the standard for Python, but that's not right now. In fact, there's a very popular project called Pydantic that they paused the rollout of this feature because Pydantic makes heavy use of type annotations, and because of when annotations are evaluated, it gets really complex. They depended upon the behavior of the old way of doing it. So they pulled it back and said, all right, we're not going to roll that out yet. We'll figure out how to make this work with this project, because Pydantic is used in FastAPI, which is a framework that is like taken off over the last couple of years and is really popular. And so they didn't want to just blow up a bunch of people's code inadvertently. Like the Python community tries to be pretty reserved about their breaking changes in particular. And that's a good policy. I think it's served the language well. So they have to be a bit more thoughtful about how they do this. So it is coming, but I think there's more work to do before it becomes standard. For now, you can use the from future import annotations thing. All right, let's move on to another example. Any questions about that one? That one's a bit esoteric, perhaps, but
It's just like enabling an experimental feature, or maybe it's not necessarily experimental, but
yeah, it's enabling an optional feature. And that feature is not a new thing. So if you can go look at the Python documentation, classic example is the jump from Python 2 to Python 3. And I see some head nods from Collins, who's the other old timer with me here. There's a from future, it's the print function. So if you know Python 2, print used to be a statement, which just meant that it was like a keyword that didn't require parentheses. In Python 3, it was forced to become a function. They removed it as a statement and turned it into a function. So the from future use print function was the way to make that file think of print as a function instead of a statement. It was allowed to help teams transition their Python 2 code to Python 3. So it's essentially, the future import is like a compatibility layer if you're needing to do some transition stuff. Okay.
Could you insert it inside the class?
The future?
Class method?
That's a good question. I actually don't know what would happen if you put an you're talking about like put an import right here?
From future, yeah.
I have no idea. I don't know the behavior.
Doesn't like it.
Okay, well this is just maybe, but this is a Pylance error. This is not necessarily a Python error. Yeah, I don't know. Good question. I literally have no idea what would happen if I did that. It'd be a fun experiment, something to try when you go home. All right, let's move on to our fifth example. So here we go. We've got a function. Whoops, that's not a function, which I'm going to call iterate something, and it's going to take a something. And I'm going to use a list. And so we're going to do for thing in something. We want to print the thing. I know I'm being super descriptive with my variables. So this works fine if you have a list. 1, 2, 3. Okay, but you can iterate more than just Python lists. There's plenty more you can iterate. You could iterate, so we can iterate something, and I want to say, I want to iterate through a tuple, which uses the parentheses syntax instead of the square brackets. And you can even iterate over an individual string and go through each character, one character at a time. That's allowed. So there are multiple things that are iterable, hint, hint, that this function doesn't allow, even though this should work just fine. Like this in theory, the body of this function should be able to go over that thing and print 1, 2, 3 if it was a tuple, or print HELLO if it was the string of hello. So the problem here is that the type is too narrow. It's a list. It's only expecting a list. And the way to correct that is to expand it with something that is a stand-in for anything that acts as an iterable. So again, this will come from the typing module, as we saw with any. So we'll say from typing, import iterable. And now if we change list to this iterable type, we've made our code a bit more generic. It can work with anything that satisfies that protocol rather than expecting the very concrete and specific type. There's a few that are built into the typing module. There's one, I think, called mapping, and there's a mutable mapping. So if you need to do something similar with dictionaries, maybe you're looking for keys or items or something like that, you can use a mapping instead. Frankly, I've never used those. If I've ever used one that needs to be a generic, it's been this iterable example. So that's something useful to know.
Is it going to give you an error if you just put in iterate something, parentheses 1?
It should. Yeah. I think, so the question was, if I did iterate something and I did a 1, that should be an error.
Yep.
And the reason is because 1 is not, an integer is not an iterable data type. In fact, it tries to tell us it's iterable. His type of int is when it's expected. And here we go. There's that implicit any. It appears there. So when we're saying, like, we could say iterable of type string, in which case our things up here are going to blow up because now they're like looking for, or it's provided integers, but I gave it the wrong type. So you probably should be a little bit more specific if you're looking for particular types inside of your list-like things. But yeah, that was a good example with the integer thing. All right, final example. This is a cool one. This is called a data class. All right, so I'm going to type out the code and we'll talk through it. And then we need to go to the top and we need to go from data classes, import data class. All right, so y'all can stare at that class for a moment more, and then I'm going to put in just a couple of examples of usage. And hopefully you're seeing already how VS Code is trying to help me out. So recognize that I've created this class thing. Like, I didn't define an init function there, and look what it did already. It's pretty cool. All right, and then we get stuff out of it. Title. I'm sure I could do this faster ways, but VS Code is not my preferred editor. So if you're like, man, he's so slow, I'm
jealous enough to actually talk with you.
okay. So this is a way to describe like a generic data object, and it's a very concise way to do it. Like, we didn't have to specify a lot of boilerplate code. There's a lot that this data class thing is doing for us. I can't even go into all the things. That would be a whole other talk explaining everything that that data class does for you. If you were to do this in another way, like, let's just imagine that we're trying to make a close equivalent class, and I'm gonna point out that this is wrong. This example that I'm about to show you is incomplete compared to what the data class is doing. But I'm going to attempt to simulate the same kind of thing. So we're going to do a title with a string, genre with a string, and a year with an integer. And then we're going to do this dot title This, oh my word, what language am I in? Sorry, y'all. Jeez. I've been working on a Java project in my free time. It's embarrassing presenting on Python and use, goodness. All right, so almost there. So this is, and I'm going to call it movie 2. That's probably what it's complaining about. This is a similar but different class. The data class did a bunch of things for you that you didn't even know. Like if I'm comparing instances of movies, is it the same movie? Well, how would you determine that? I mean, you might do it based on, hopefully you could do it based on title. Maybe there's some unique motion picture identifier. In fact, I know there is. Like the logo at the bottom of the MPAA, is it MPAA? They put some like number of, here's your movie number. So you could have some unique identifier, but by default, Python, when you try and compare two instances, they're not going to know how to compare. So you might need to use a special magic, quote unquote, magic method of dunder EQ, so like a test for equality, and define that thing. Well, guess what? Data class probably, it did that for you when it built this thing. And all you had to say was, here are the attributes that I want. And here's the type that they are, so that you can do the right thing and create the right constructors for me. And then when it came time to actually construct the instance of it, it built that init for us. And it told us, okay, it's got to have a title and a genre and a year. And it goes based on the order that you declare them in the actual class constructor here. That's not really a constructor, but the class declaration. So that is a data class. It's very powerful. It's a good way to just pass typed objects around rather than, there's an anti-pattern in Python and a lot of these dynamic languages. It's called primitive obsession. And the idea is overuse of dictionaries and lists and passing those around everywhere, where you might otherwise benefit from, if I named this thing and gave it a domain concept, then my editor could help me because, oh, I passed in a movie instead of a dictionary that looks like a movie. See this? It's a subtle semantic difference there, but you can get a lot more powerful code if you try and add a little bit more description to give things more definitive types. So that's what I've got for you on types. Hopefully you learned something about type hinting, type annotation, just about types in general in Python. Are there any questions?
How long before artificial intelligence removes the needs for classes because it figures out what you're actually asking?
I don't know. If you've been watching the whole chat GPT thing, the computers are coming for our jobs, apparently. I think there's a world where we'll find ways where AI can do a lot of the grunt work for us and save on typing. It'll be more of a tool than it will be actually replacing human thought, because if you think about it, those AI things, they were trained on real people doing real thought work. There's a long while before we get to general artificial intelligence.
Well, I've actually heard that they're beginning to develop engines to help you code.
Yeah, they exist. Mm-hmm.
Yeah.
GitHub Copilot is
Yeah.
probably the most popular one these days. But
Is it tab 9 also one?
yep, there's a lot of competitors out there that are trying to do the same thing.
Is it sloppy? I guess I assume it is to do type hinting with your inputs but not your output. I guess that would work.
Good question. The question was, is it sloppy to do type hints for your input but not your output? I want to say that in order for type checkers to even recognize it, they expect an output as well. I don't think you can do one without the other. I think it's considered like incomplete, and it will ignore it. Somebody can check me on that. I think that's the case, but
I struggle with the muscle memory. Yeah, I just have to one of the tricks for like learning list comprehensions is to just keep writing them over and over and over again until you've like gotten muscle memory. That's what I need to do with type annotations.
yeah, I have found you can sprinkle type annotations. This is the great part about it. It's it's not a fully static language. So nobody's telling you, unless you're at my company and we've gone through the process of putting in code checks, nobody's telling you that everything has to be type annotated. In fact, it'll probably slow you down initially, at least, if everything was type annotated. So if you have a project that you're like, I have this function that for whatever reason, because 3 people behind me put in 10 parameters on it, I can never remember what all the parameters are supposed to be, maybe type annotate that thing and get the benefit of, like, next time you have to call that crazy function, you have all of the information right at your fingertips. Oh, this needs to be a Boolean. Oh, this thing that's named is foobar is actually a string, like where that crazy kind of stuff happens. That's where types can be pretty powerful to introduce. There's even a name for it. It's called gradual typing, where you kind of ease into it and bring it into your code base.
You'd be surprised how many errors you find in working code.
Oh yeah,
Oh
yeah.
my God.
Real errors lurk out there because people didn't think about stuff. You could probably even let loose MyPy or PyLance on an unannotated code base, and they could probably surface some things. And it's going to treat just about everything as any's, but there's additional smarts in there where it might find an integer constant that you put in there. So MyPy is able to figure out, oh, I haven't seen that thing change, and it was assigned an integer, so I know it's an integer, and then I can see some operation that's not allowed on integers and say, like, I don't know what you did here, I don't know why you did it, but this is wrong. So you can start there. Teams can put it in their continuous integration tools. It's pretty easy to add. There's very advanced configuration, so you could even kind of quarter off different segments of a project and say, this area now I expect here and forevermore to have type annotations on everything. So you can progressively, that's how we did it. My company had a very big legacy code base, 500,000 lines of code. There's no way that we could type annotate all of that in a single PR. We would be absolute madmen if we did. So we went chunk at a time, and then in our configuration file continued to, like, ratchet things up until over time everything was type annotated. If that's your goal. That was our goal, because on a team of our size, it had real benefits for our members. But that's just something to consider.
I think there are some, like, MyPy linters you can configure if you want to say, this project must always have type hints. I think there are ways that you could do that. That's a pretty aggressive approach, but.
Correct. Yeah, and MyPy itself has varying degrees of aggression with how serious do you want to be about your type hints. We saw a bunch of examples today where we had the implicit any. There's a way to turn that off so that MyPy says, like, no, you cannot have any anywhere. And that's like hardcore mode with typing, and really almost transforms Python in like a different programming language at that point. It gets very, very serious about it, and there's companies that go that route. So you can, it's a whole spectrum of how rich do you want your information to be in your code editors, and I think that's pretty great.
I mean, so could you use the type hints to, I guess, enforce polymorphism?
Yes. The question was, can you use type hints to enforce polymorphism? Well, I don't know if you can enforce it, but you can. There's extra concepts that I didn't cover here that are a bit more advanced. You can look at, if you go to the MyPy documentation, or if you want to read the PEPs, which were probably a little bit more dry, there are things called protocols. So you kind of implement a class that represents the thing that you're trying to be polymorphic about. It's a way of doing the duck typing thing that we saw there. Like, how would a function do the duck typing thing that we saw? There would either be two methods. One would either be to say it's a union, and the union is either a duck or a Dr. Nick in the example and nothing else. Or you can implement a quacker protocol and say anything that has a quack method with this signature is now something that can be used by this function. So it takes it from the concrete implementations to the general idea of what you were trying to represent. Does that make sense?
No, I was just trying to think of, like, because method signature being different depending on how you put the type hints in there. I don't know whether it would, I guess, directly you should be smart enough to know, oh, I want to use this one as opposed to this one because it fits this one's signature.
Yeah, in that case, if the body of the function that you're using expects to use the object differently, then you're going to have to get a little bit more complex in what you're specifying as your input arguments, and do some appropriate guards and checking.
I guess I'm used to using more statically typed languages. So.
Yeah. Yeah, the power is in there, but and this is where it kind of type hinting is a friction in some degree with dynamics, like dynamic stuff. If you go all static typing, you're going to lose out on some of the things that are available to Python. There might be ways to do it, but the first one that comes to mind is like if you're trying to use set adder or get adder, like the really, I'm looking for attributes that happen to exist on this object, and I'm doing it very dynamically. Like that kind of stuff makes my pie cry. I'm sure you could figure out ways to do it. I don't know them off the top of my head, but there are things that are on the most extreme dynamic end of the spectrum, which some developers love, which is why those developers like hate and rag on MyPy. So like the cool part about MyPy is that, again, this gradual idea is that you can live on, you yourself can live on that spectrum of this is how much typing that I like in my code. I can either be the hardcore, I think static types are super amazing and I want everything to be hammered down to the T because I think it's going to make my life better, or you can live in like, I don't want any typing, and like I like my Python the way it was back in Python 2, or like whatever your stance is. I think that's pretty cool.
Aside from the warnings in the IDE, what type of error does Python give you if you run one of those functions wrong?
Oh, this is a really good point. So Michael's question was, what errors do you get on the functions? Because it's optional, the runtime pays, well, this is not totally true, but the runtime tries to pay zero attention to the annotations. Normal Python code, assuming you're not trying to use some annotation API to do introspection, is going to ignore all type information that's there. So assuming you, like, let's say going back to that first example where we had, I think I had it as like string. So we get the squiggle here. The type checker is telling us, but remember, that's a different tool. That's not Python, the runtime itself. So you could run this code. In this case, it wouldn't do anything because this George variable is not used. But if you imagine that we tried to do something that required a string and you passed in 42, then you're just going to get a runtime error in your code. You'll get an attribute error or type errors. And like, there's no guards that's saying like, because I'm using a type checker, it's magically like fixing the calls. Like you have to actually fix the problems. And otherwise Python's just going to happily, blissfully try and execute your code anyway, even if it's wrong.
Okay, so it doesn't have any effect on at runtime?
No effect on runtime. Unless you're there are, like I mentioned, Pydantic tries to do fancy things where they use like introspection to look at the types, and like the data class that we saw at the bottom, like it's building the class out of that type information. So it's not to say that you can't use the type information, but by default, it's ignored.
Okay, so I guess that sort of answers presumably my second question, which is why is it called hinting? Type hint, right?
Yeah, the official name is a type annotation,
okay.
Which I guess implies that it's like extra metadata. Right.
Okay.
Right. But type hint is the kind of casual name. And type hints, like type hints are things you'll find in a lot of languages. Like JavaScript has, well, that's not true. They have TypeScript where, anyway, there are languages where you have optional typing available to you. Erlang, there's one that I know of, where you can kind of gradually add type stuff to your code. And type hint is just a name that you'll kind of find in the industry.
Okay. Doesn't JavaScript have the var type?
So JavaScript variables can be var or const or let, and depending on the JavaScript version you're on. That's less about the type and more, how do I even describe those? That's more about what the kind of the variable is, like the container of the variable. Is it constant or is it mutable, like lexically scoped, or like that? It's sort of at a semantic language layer that's not necessarily about the data, but more about the way that you're using those constructs. I'm sorry, I'm using a lot of like
We had the JavaScript
crazy
guy
terms here.
last month.
What's that?
We had the JavaScript guy at dinner last month.
Oh yeah, yeah.
Oh.
So I'm happy to dig into outside of that. Yeah.
We should do a JavaScript class. The Python meetup.
You know, we should say, somebody should. I'd love to hear a talk on PyScript, which is like the WASM WASM Python project that is in the browser. So it's not JavaScript. It's actually deliberately like not intended to be JavaScript. It's like a different thing that you could run in the browser. That would be a really interesting topic if any of you have experimented with it. Any other questions about types in Python or type hints or anything you've seen?
Have you tried passing regex into this, like the regex, compile regex, and pass it in as a type?
Yeah, so the standard library has, all of those things have types themselves. I think it's a regex. I think that's the name of it's a class called regex that you would, so if you needed to say, you know, this is my regex, terrible variable name, but the regex module, and this is where I don't remember, you look inside of the regex module, I'm probably getting this wrong, but
That's fine.
you could look up types from other areas and then add them appropriately.
So you're essentially calling a function that'll check your type for you in that case. And the regex is a type checker, so, okay.
Yeah, it's saying, the type hint system is saying, I am stating that I want a regex class in this case, or I want this thing because I'm going to do something with it that I expect this data type.
Is there a super type for type hinting things that can be evaluated to a Boolean?
Is there a super type for type hinting things that can be evaluated to a Boolean, like something truthy?
Yes.
I don't know. I honestly don't know. We might. All right, let's look a little bit.
I've run into the problem where you think you're checking a condition on a Boolean, but actually it's a list or it's none. And
Yeah.
Python generally doesn't complain about that, and each of those things have their own behaviors for whether they evaluate the true or false. But I'm curious if there's a way that you could tell it, like, I want to pass in anything that could evaluate the true or false.
Yeah, I don't, Mike, I don't truly know the answer for you, but I will point you all to this page. So this is the MyPy documentation. You can Google it. It's at Read the Docs. Probably most useful if you're getting into this is this type hints cheat sheet, which kind of walks you through a lot of the things that you saw tonight, and kind of explains, you know, there's tuples. We didn't talk about sets. There's all sorts of cool stuff in here. There's callables. There's a ton of stuff. There might be something for Booleans somewhere in the docs, but I gotta confess I have not read the documentation for MyPy in quite a while, so I don't know off the top of my head if there's a truthy kind of generic. But this is a good reference to have. Any other questions? Cool. Thank you all. It's been fun.